All right, section 6.5. That's supposed to be a circle. And it's supposed to be a special circle. It's supposed to be our nice unit circle. Like so. And I want you to tell me a point on this unit circle, maybe right about here. So somebody give me a reasonable x number for right there, that point I drew. 4 is not a reasonable x number.
0.7.
All right, how come 4 is not a reasonable x number? Because the biggest x value on the circle is 1. So 4 can't be a reasonable answer. So 0.7? 0.7 is a reasonable answer. If x is 0.7, what's y? I don't think so. Might be close to 0.6, but I don't think it's 0.6. Well, here's what we have. We have this distance is 0.7. What's this distance? 1. Why is that distance 1? Because it's a unit circle, because the radius is always 1. So how would we find the y value? Our good old friend, the Pythagorean theorem, right? So we would have x squared plus y squared is r squared. So 0.7 squared plus y squared is 1. What's 0.7 squared? So 0.49 plus y squared is 1. So y squared is 1 minus 0.49? 0.51. So y would have to be the square root of 0.51. All right, so now I'm going to call this angle right here, I'm going to call this angle theta. And I want you to tell me the sine of theta, the cosine of theta, and the tangent of theta. What's the sine of theta? Square root of 0.51. Why is it the square root of 0.51? It's opposite over hypotenuse. And the hypotenuse on a unit circle is always 1. So remember we talked about sine is y over r. But in this case, if you're on a unit circle, r is always the number 1. So on a unit circle, sine of theta is simply the y value. By the same argument, what's the cosine of theta on a unit circle? Simply the x value. So it's going to be 0.7. Because it's x over r. That's just x because r is 1. And how about the tangent? Y over x, square root of 0.51 over 0.7. All right, now I'm going to take this point right here, and I'm going to reflect it over the y-axis. What does it mean to say take this point and reflect it over the y-axis? This point goes over there, doesn't it? I just mirror image. All right, so there's that point right there. What are the coordinates of that point? Negative 0.7 and positive square root of 0.51. Okay. I'm now going to draw this angle. This angle I'm going to call alpha. I want to know the sine of alpha, the cosine of alpha, and the tangent of alpha. What's the sine of alpha? Square root of 0.51? How come? It would still be opposite over hypotenuse, or it would be y over r. Y is square root of 0.51, r is 1. How about the cosine of theta? Or cosine of alpha, I mean. Negative 0.7. Why negative? Because it's in quadrant 2, and the x value in quadrant 2 is negative. And how about the tangent? Negative square root of 0.51 divided by 0.7. So, what can you tell me about the angles theta and alpha? They're the same, basically. Besides the negative signs. All right. Can you give me a different terminology for they're basically the same, except we have dealings with negative signs? Not inverse. Not reciprocal. It begins with an R, though. Well, they are reflections. That's true. That's not the R word I was looking for. What's this angle right here? Same as what? It is the reference angle. That's the word I was looking for. How are theta and alpha related? Theta is the reference angle. What if I were to take this same original point and reflect it over the x-axis and end up down here? It would be the same all over again, wouldn't it? Except for the pluses and the minuses. Because my reference angle would still be theta. What if I took this point here and I told you reflect it over the origin? What would it mean to reflect over the origin? Put it in quadrant 3, and then what can you tell me is going to happen? Everything's still going to be the same except for the pluses and minuses. So if I reflect over here, this is still going to be my reference angle theta. So sine, cosine, tangent, they'll all be the same value, except we'll have to watch our pluses and our minuses. All right, so that's kind of a handy thing. Once you know the sine, cosine, and tangent for one angle, you really know the sine, cosine, and tangent for 1, 2, 3, 4 angles. All right, so what's the sine of pi over 3? Pi over 3 happens to be the same as 60 degrees. That's correct. So what's the sine of pi over 3? Square root of 3 over 2. What's the sine of 2 pi over 3? First off, where is 2 pi over 3? Quadrant 1, quadrant 2, quadrant 3, quadrant 4? 2. Why is it in 2? Because 2 pi over 3 is just a little bit less than 3 pi over 3, and 3 pi over 3 is regular old pi. So this is in quadrant 2. What can you tell me about sine in quadrant 2? It's positive. So what's the sine of 2 pi over 3? Pi over 3 looks like this. 2 pi over 3 looks like that. What can you tell me? How are pi over 3 and 2 pi over 3 related to each other? If I were to pick a point right here and I reflected it over, it would look like so. So what can you tell me about pi over 3 and 2 pi over 3? They're really the same angle. Well, they're not really the same angle, but their trig functions are all the same, except for maybe pluses and minuses. So what's the sign of 2 pi over 3? Square root of 3 over 2. In other words, what I'm telling you is your reference angle right there is pi over 3. What's the sign of 4 pi over 3? Well, the first question you should ask yourself is which quadrant is that in? And you're going to tell me it's in quadrant 3. Why is it in quadrant 3? It's a little bigger than pi. 4 pi over 3 is a little bigger than 3 pi over 3. In quadrant 3, sign is negative, so the answer is negative square root of 3 over 2. And finally, I might ask you, what's the sign of 5 pi over 3? And I hope you would very quickly tell me the answer now that you've seen a pattern. Negative square root of 3 over 2. What's the cosine of pi over 4? Root 2 over 2? You didn't say that with a lot of confidence. But it is correct. What's the angle in quadrant 2? Cosine is negative in quadrant 2, so I'm going to get negative square root of 2 over 2. What's the angle in quadrant 2 that has pi over 4 as a reference angle? Three pi over 4. Why 3 pi over 4? Because it's a little bit smaller than pi. It's a little bit smaller than 4 pi over 4. How about the angle in quadrant 3? What's a little bit more than 4 pi over 4? 5 pi over 4 is a little bit more than 4 pi over 4. And how about the angle in quadrant 4? 7 pi over 4. Or you could have written it as minus pi over 4. You could have given me a negative angle too. That would have worked. All right, so we'll do more of these on Friday. But I guess what I'm working towards is remember how I told you better memorize that chart? You also better know it in radians. So again, if I call you at 3 o'clock in the morning and ask you, what's the cosine of pi over 3? You're going to tell me? Quit calling me at 3 o'clock in the morning. But then your next answer will be, what's the cosine of pi over 3? 1/2. All right? So you should go home. You should fill in this chart. And it's written in the same order. It's 30, 45, 60, 90. Fill in that chart and then memorize it for Friday.